Hi. Now, in this next part of the question, working off this identity that we're given, it's given that there are two values of theta, where theta is greater than minus 90 degrees and less than 90 degrees, satisfying the equation 6 cos squared over third theta plus 45 degrees minus 3 times cos of 2/3 theta minus the sine of 2/3 theta equals k, where k is a constant. And what we've got to do is find the set of possible values of k. So if you'd like to have a go at this and haven't done so already, just give you a moment to pause the video, do come back when ready, and you can check your work solution with mine. Okay, so for this question, what we've got to notice is that we can generate this equation here by taking our identity that we're given and multiplying throughout by 6. Okay, so we've got 6 times a half there, which is going to give us that 3, and then this is identical to 6 sine squared theta. And in this example, comparing the two, what we're doing is we're replacing any theta here with a third theta, and you'll generate a third theta here, and when it comes to cos 2 theta, you'll be doing the cosine of 2 lots of a third theta, which will be cos 2/3 theta, and the same applies to sine 2 theta, gives you sine of 2/3 theta. So I can pick up on that. So because this was identical to 6 sine squared theta, then I can replace that theta then with a third theta and say that therefore what we've got is 6 sine squared a third theta, okay, must be equal to the constant k. And from here on, if I divide both sides by 6, I therefore have sine squared of a third theta must be equal to k over 6. And then if I take the square root to both sides, we therefore have the sine of a third theta, okay, equals plus or minus the root of k over 6. Now, we're told that theta must lie between minus 90 degrees and 90 degrees. So what I'll just write here is that since, okay, theta lies between minus 90 degrees and 90 degrees, what does that mean? Well, it means that our angle for a third theta, let's just put it down here, therefore a third theta, or theta over 3, if we divide each of these two angles by 3, we get that a third theta must be greater than minus 30 degrees and less than 30 degrees. So what that means is that to get the set of possible range of values of k, knowing that sine is an increasing function over this interval here, what we need to do is take the minimum value and the maximum values that this can be within this range, and that will be minus 30 degrees and 30 degrees. Let's just draw it out on a quadrant diagram over here, where this is 0 degrees. So what I need to take is the sine of 30 degrees and the sine of minus 30 degrees, these two angles being exactly the same, set at 30 degrees there. That would be a magnitude 30 degrees, but as an angle it would be minus 30 degrees. So I've got my range here for theta over 3. So we're looking then at the sine of 30 degrees. Sine of 30 degrees, we should know, is equal to a half. So what we're going to have here for the sine is plus a half, and for this one, being in the fourth quadrant, sine is negative, this will give us minus a half. So therefore, just taking the positive value here, because it's going to be symmetrical, I can see that therefore the root of k over 6 must be less than a half. If I took the sine of any angle less than 30 degrees, it's going to be less than a half. So if I was to square both sides now, I would therefore have k over 6 must be less than 1/4. And if I multiply now both sides by 6, we end up with k being less than 6/4. And 6/4 reduces down to 3 over 2. But we've got to be careful here, because k in fact cannot be a negative value. You can't take the square root of a negative value. So I'm going to say here, okay, we'll just put in another column here, but k has to be positive. It has to be greater than 0. So therefore we conclude that k must be more than 0, but at the same time less than 3 over 2. Okay?